As part of our Smithsonian Associates Art of Living series, our guest today on the Not Old Better show is Dr. Sarah Shomstein. Born in Kiev, Russia, now the Ukraine, Sarah Shomstein is an associate professor of cognitive neuroscience and director of the Cognitive Neuroscience Program at the George Washington University. Her research interests are focused on investigating the neuromechanisms of attentional selection by combining both behavioral and neuroimaging techniques in normals as well as brain-damaged populations. According to Dr. Shomstein, because the brain isn't able to process the amount of information coming at us all at once, it has developed a way to select a subset of information for further processing. The critical question, she says, is how the brain chooses what to process first and what to process next. She addresses the science behind that question and suggests ways we might enhance the brain's ability to keep us focused. We'll be paying attention, absolutely. In her spare time, Dr. Shomstein plays squash, she skis, she scuba dives, travels, attends art exhibits, and perfects her photography skills. Give a listen to today's show featuring a very interesting subject. This is personally very interesting to me, told by a very interesting person with great science, passion, and research by her side. Join me in welcoming Dr. Sarah Shomstein. Well, Dr. Shomstein, I found so much about you online. I really could talk about this subject for many hours. As I say, I am very personally interested. You, of course, are going to be talking about this subject for at least 2 hours, October 19th, 2016, at the Smithsonian Associates Program series. But I found a quote of yours that I really like, that I think might be kind of an interesting place to start. And I'll just read that quote. Representing the visual world efficiently requires selecting a fraction of the multitude of information that is available to the visual system at any one instant in time. And when I read that, and I read it a couple times because I thought it was so good, I thought to myself, is that kind of the same thing as hidden in plain sight? And maybe you could tell us a little bit about what that quote means to you in relation to your talk at the Smithsonian. And I think it also brought to mind a Steve Jobs quote where he says, focusing is about saying no. But I wonder if you just comment a little bit about your quote, what that means, and if that really is kind of this idea of it's hidden in plain sight.
Of course, and thank you for having me on your podcast. Well, to answer your question, as people, we are acutely aware of our physical limitations or limitations of our environment. For example, I can't hold more than 2 large objects without stacking them because I only have 2 hands. Or I can't run faster than, say, 28 miles per hour, and even then I'd have to be Usain Bolt.
Right.
Or I can't see further than, say, 3 miles because the Earth's surface curvature is out of sight. And I can go on with these examples. But we are less aware of our perceptual limitations. And this is when the study of attentional selection, that is my area of expertise, has a lot to contribute. Even though we feel that as soon as we open our eyes, in front of us is this meaningful and coherent world, the hard truth is that there's too much information for our brains to process all at once. So actually, behind the scenes, the brain attempts to quickly process small subsets of information at a time to arrive at that kind of seemingly coherent interpretation of the world. So in that way, as you say, if some sensory information was not selected for processing by our brain, then it is equivalent to being hidden in this kind of plain sight. Mm-hmm. And to actually get to the second part of your question, the one about Steve Jobs' quote about focusing is saying no, I think it appears to be a very good kind of analogy for how attentional selection is instantiated in the brain. Yes, in fact, information that our brain processes is facilitated, meaning that we react to it faster or we're more accurate in describing it. And at the same time, the information that is not attended is inhibited, with the consequence that we have poor perception of it. So we're slow to it, we're less accurate. So it is kind of a brain's way of saying yes to some information and no to others.
So the brain is kind of filtering some of that stuff out even on its own. Is that what you're saying a bit? Precisely.
This is the kind of to me, it's kind of a dangerous realization that the brain makes decisions of what it is that it's going to process and say yes to, and what it's not going to process and say no to. And during my Smithsonian lecture, I'll show a couple of examples that show kind of these limitations and the decisions that the brain seemingly makes without our conscious perception or consciously deciding what to attend to.
Well, as I say, again, I just think this subject is fascinating. I think seeing you there at the Smithsonian talking about this is really going to be interesting, because I think we really think, I suppose the myth is that our brain really is kind of active all the time, but it seems like our brain knows that it needs some downtime in order to really kind of digest things properly that we experience, and maybe that's why sleep is so important. So is sleep kind of tied in with some of your research even?
Well, I don't myself study sleep, but you really put your finger on it. I think it's really important to, as we go throughout the world during the day and we acquire so much of new information that we have to deal with and incorporate into our already existing knowledge, this need for sleep becomes really important, and some of the hypotheses are exactly the ones that you put forward, is to consolidate that information. But unfortunately, I can't do it all, so I myself do not study sleep. In fact, I need more sleep.
That's good. Yeah, I do too. I may need a nap after we talk today too, Dr. Shomstein. The subject of your talk is your brain in a digital age, and I wonder if, as we experience all of these, stresses in our daily lives, all of this increased activity, does technology just add to that, and does it add to it almost in a more heightened, deteriorating way? Does it even act more aggressive with the brain?
Well, as I alluded to in our conversation already, even though our brains are these extremely complex and powerful information processing machines, there are some very clear limitations to what our brains can do. And one of the most understood limitations of the human brain is this inability to process more than a subset of information at any given moment in time. So the brain is, at the same time, is under extreme pressure to make sense of the environment. So it makes best attempts to analyze as much information as possible. So as such, even in a seemingly non-overloading environment, imagine yourself looking at a serene, almost static scene. Maybe you're sitting on a park bench looking at some trees or something. And there, even with this kind of simple, serene, calm environment, there's a selection mechanism that is at work, where some subset of information is selected and others is filtered out. Now imagine that you're looking at the same scene and you have music in your ears through the earbuds. You have your phone keeps vibrating, with your text messages from your spouse, and you're getting email notification. Right. So there is an increased demand with the technology. So the point here is not, I think, is not to demonize technology, but to really understand that technology brings more sensory information for the brains to be processed. As such, there is more competition for our attentional system. So it is not an overload per se, but an increased demand is what the technology brings with itself.
Mm-hmm. Yeah, and that's a good way of putting it, that the technology absolutely should be working for us, not against us, and we shouldn't view it as a kind of a demonizing effect. I think that this whole area of the brain and the brain studies and brain science, it is very much a subject of great attention. I think as we in our society are living longer, more and more headlines and articles and research is being done on this subject, and certainly all of your great research. But I think, do you feel maybe that we're at this tipping point in terms of, maybe, drawing the line between what's good, solid information, and that is, what you're sharing, and what might be considered just kind of hyperbole around this subject, almost like, the subject du jour, and maybe just as we all think of green tea as being the the salvation, and do these brain science apps that are on smartphones, do they offer solutions for us in terms of brain training and stimulation, or do they are they really just kind of bunk?
Yeah. Let me start by saying first that as scientists, we have an obligation, and this is something that I really take quite seriously, to take findings that we observe in the laboratory and communicate it to the larger community, to the general public. Having said that, right, media has a tendency, and you alluded to it in your question, to popularize and to simplify laboratory results that have to do with discoveries in the realm of the human brain. I would say that even 20 years ago, I don't think we knew enough about the brain to clearly articulate major findings to the general public. The brain is immensely complicated, and by extension, the discoveries are also complicated in nature. We should resist this tendency to oversimplify when it comes to media reporting. However, with recent advances in behavioral, physiological, and neuroimaging methods, we are at a tipping point, as you say, where findings observed in the laboratory can have direct impact on people's lives. Whether it's the brain applications, I'm not ready to weigh in because I haven't seen hard data to support that they actually have anything to do with, say, defraying aging or anything like that. Mm-hmm. But for example, my colleague here at George Washington University, Dr. Stephen Mitroff, works very closely with Transportation Security Agency, TSA. Mm-hmm. And what he does is he applies some of the findings that he observes in his laboratory during different types of visual search tasks, and he applies it to TSA environment to increase TSA's ability to find threats. So this is a direct application. Yeah. So with more solid understanding of how the brain works, there will be more solid information coming out to the general public. For now, I think that all brain-related news should be met with a healthy dose of skepticism. Mm-hmm.
Yeah, and I think that's a really good point. I think that erring on the side of maybe just questioning and maybe a bit of caution, and just understanding that there needs to be an actual science behind some of this discussion before we just jump to some of these conclusions. I want to get back to this idea of how the brain chooses, because I think that's really very a really important one, and I think it's a big part of your discussion, certainly at the Smithsonian. But if you could maybe talk a little bit about the area that my audience is going to be interested in, and that is, if the brain is choosing, does it become weaker in terms of making its choices as we age, or does that function stay, somewhat even across different age bands? And is there a way to kind of boost and aid in this function of making the brain choose better?
You ask, the very incisive questions and the very important questions. The answers are going to be perhaps underwhelming, but then again, because of the complexity of the system that we're dealing with. I think that power comes with understanding. If as scientists, we learn how the brain chooses what to attend to. In attention, we call it an attentional bias, or this choice that the brain makes. We can figure out what determines the choices, which choices are susceptible to conscious overrides, which are just hardwired, which say degenerate with age, right? As you point to. As we learn more and more about the system when it functions properly and at the maximal peak, then maybe in the very near future we will be able to give our brains a boost. Okay, maybe through the apps, maybe through mental exercises or something like this. For now, I'm afraid we will need to be content with more of a cautionary tales of understanding our limitations and acting accordingly. So knowing that we cannot process all of the information at once, meaning that when you're driving and talking on a cell phone, as you get more engaged with the conversation, you are taking brain resources away from processing what is happening on the road, right? And kind of allocating more towards the conversation. So understanding the limitations and applying them to our kind of everyday activities is a first step. And as a next step, I think very soon, my prediction is, within the next 5 to 10 years, we'll be able to use what we have learned about the normal functioning of the system to try to augment it, to prevent, to not prevent aging, but to, have what we call healthy aging.
Yeah, and so, kind of touching on that subject of health, I know a little bit about you, of course, and I know from your own website, Dr. Shomstein, that you're very active. You play squash and you do scuba, you ski, and you're a photographer. All of these activities are benefiting our brain too, right? Is that this term neurogenesis, and is this this rebuilding of the brain a possibility? And can we think in terms of helping it along with some physical rigor?
Perhaps I should learn to disclose less about myself on my webpage.
I tend to pry, so I apologize.
No, I'm joking. In all seriousness, neurogenesis really refers to the growth and development of nervous tissue, and most often people mean kind of regeneration of brain cells. It is a very active and important branch of neuroscience right now. Lots of research is being done in this field, and again, right now the answers are complicated. Do we regenerate cells? Not really, at least not the cells that we are hoping to regenerate. Maybe cells in hippocampus, one of the major memory structures in the brain. Those do not regenerate. However, it's important to think about the brain, maybe not in terms of single cells, but rather as connections among cells. And in that regard, exercising certain mental functions, we can enhance connectivity and in some cases prevent that connectivity from degenerating with age. This is sort of, keeping agile, doing what you like, having hobbies. All of that is contributing and helping to keep the pattern of activations or this connectivity healthy and preserved. This phrase, use it or lose it, applies not only to muscles, but to this kind of normal, good functioning of the brain, this connectivity among neurons.
Mm-hmm. Yeah. And so I think that these are all exactly the kinds of things that I think we just really need to know a little bit more about. We're of course with Dr. Sarah Shomstein. Sarah Shomstein is going to be speaking October 19th at the Smithsonian Associates Program. The title of her talk is Your Brain in the Digital Age. We'll have links to the Smithsonian Associates website where you can find out more information about Dr. Shomstein as well as her talk and register. I think that this is something that as my audience really becomes a little bit more aware of, they're really going to need to know more of these kinds of fact-based, bits of research so that they can really understand it and act upon it. And I found one of your studies online also that talks a little bit about some object-based attention in real-world scenes, and I wonder, what are some of those real-world scenes? I mean, are those the scenes that we're thinking of in terms of balance, of kind of using both hands to be engaged? And are you going to be talking a little bit about that when you're at the Smithsonian Associates?
Yes, definitely. An interesting point that you bring up with this question is really the difference between laboratory studies that we do here in my laboratory here at GW and the real world, and how applicable what we find in the lab is to our everyday lives. As scientists, we pride ourselves on the ability to isolate this single variable or a single question and provide an answer to it. However, sometimes, and most of the time for me in my own work, it actually comes at an expense of real worldness. So, for example, what I mean by that is that most of the findings in my laboratory, if you look at my research articles, they're actually based on using very simple shapes as stimuli, like rectangles, circles, letters L's and T's. Okay. And importantly, real world is not composed of simple circles and rectangles. So at a certain point, it really becomes imperative to extend theories and hypotheses that we base on these very simple stimuli and extend them to the complexities of the real world. Now, the paper that you're referring to, I actually collaborated with my then postdoc, Dr. George Malcolm. We did just that. We tested the hypotheses that we've been working on in the lab for, over a decade, and that were based on this very simple rectangles, circles, and squares, and we tested it in complex environments. Now, that being said, it's not as if we had people driving and talking on the cell phone or anything like that. It was simpler. We presented participants with real-world images, so just pictures of scenes, and we tested our theories based on that. So we are kind of, I think, as researchers, at least in attention, we are at this tipping point again, where now we know enough. We've learned enough over the past, several decades, or 70 or 80 years since the cognitive revolution of 1940s, that we have these theories now that we can now actually extend from the lab setting and into the real world and actually put our theories to the test.
Right, and so some of those theories have to do with this idea of selection. And so if you're studying this in the lab, are you recreating enough of a real world environment to be able to get that kind of accuracy, or are you having to even make some leaps in terms of the research in order to really understand how this selection is taking place in the brain?
Yeah, as a healthy skeptic, I'll say we are, not anywhere near the true real world settings just yet, but we're making steps in the right direction, and I think that's the important part.
Yeah, I would agree 100%. Well, let's talk about. I really just have one other question for you, and that has to do with some of the myths that surround the brain and this idea of us, kind of being hardwired with almost a set of instructions. You think about these terms like senior moments and even this idea that frailty is inevitable. We've talked a little bit already about the idea of exercise and kind of mental stimulation. Do you think that's where some of your own research is going to go next in terms of understanding kind of overall brain power, that we need to even heighten our ability to be more selective in terms of what we're paying attention to, and that's some of the most important studying that we can do in terms of research?
Right. So your question is about kind of this hardwired properties of the system and things that we can change, perhaps. As owners of this very complex hardware that is the human brain, we're faced with a very interesting paradox. On the one hand, we change our brains every minute and second of the time. So, for example, having talked to me today or having listened to the podcast, you might have learned something new. And what that means is that you've changed your brain. You created neural representations, you created new connections among cells, or you've strengthened them. So on the one hand, our brains are extremely plastic and we can change it, which means that we can maybe overcome some of the aging effects with this kind of exercise. On the other hand, as I said, this is a paradox. On the other hand, our brains are hardwired, as you say, and we have what's called, extreme localization of function, such that certain functions are subserved by particular neural structures. And if you are to lose that neural structure, stroke or through traumatic brain injury, it's impossible to get that function back. For example, there are stroke patients who have damage in the temporal lobe that's in the region along the fusiform gyrus, and as a result, they're no longer able to recognize faces. And what's really fascinating and terrible at the same time is that no amount of training can bring it back. So, you see, I think the answer is, again, more complicated than we'd like or than I would like. For some functions, you can get better, you can change them, right? You can overcome senior moments with practice, perhaps. But for others, we're really at the mercy of the hardwired properties of the brain. And as scientists, it's important for us to really elucidate which abilities are plastic, right, and can be improved, and which are hardwired, and armed with that knowledge, create different either therapies for brain damage, or even kind of these exercises for healthy brains.
Fascinating. Well, Dr. Sarah Shomstein will be at the Ripley Center in downtown Washington, D.C. on October 19th, and that's going to be at 6:45 p.m. I certainly am going to be there. Dr. Shomstein, I'm looking forward to meeting you. I think this is a subject that is changing greatly, rapidly. I think you're somebody that we're going to want to talk to and stay in touch with over the next many months because of what your own work is, and then, of course, interest from the Smithsonian. But this question of the science behind our processing and our gathering of information is just a real interesting one. And so thank you very much for joining us today on the show, and we look forward to seeing you on October 19th, and certainly we will be paying attention. So anything else that you'd like to add today?
No, thanks for having me, and I look forward to my talk at the Smithsonian and taking questions from the audience. It's always, I'm sure it's going to be a lively discussion.
I'm sure it is. Thank you very much, Dr. Shomstein. Thanks to all my guests today, all the help on the podcast, and especially to Media Studio Edit and the great work by Wayne Brown and his team for editing the podcast and making me sound so much better. That is to say, not old, but better. Thanks to all.